Hi everyone, thank you so much for clicking onto the video. Today we're going to be learning about rate determining step. So our learning objectives are to, for a multiple step reaction, predict the rate equation that is consistent with the rate determining step. And we're going to learn about possible steps in a reaction mechanism from the rate equation and the balanced equation for the overall reaction. So now I'm going to talk about how to predict reaction mechanisms from the rate equation. So the rate equation only includes reacting species involved in the rate determining step because these are the only reactants that determine the rate, and the orders in the rate equation match the number of species involved in this rate determining step. So the overall method is that firstly we summarize the information we know from the question, and then we compare the overall equation with the information from step 1 and note that the sequence of steps must add up to the overall equation which is given. And then the last step is to identify the intermediate and work out the two-step mechanism. So we're going to have a look at this quick example of CH3 3CBr plus OH minus goes to form CH3 3COH plus Br minus. So the rate equation has been stated as rate equals K multiplied by the concentration of CH3 3CBr, and we're going to propose a reaction mechanism. And so for the first step, summarising the information we know, so we know that the rate equation shows the rate determining step. So we can see that only the CH3 3CBr determines the rate. And so this must be the thing that's involved in this rate determining step. And OH minus has no effect on the reaction rate because it's not involved in the rate equation. And so this must be involved in the fast step. For step 2, I then write out the bits that we know. So we know that CH3 3CBr is part of the slow step, and adding OH minus to something is the fast step. And then I've written the overall reaction as well. And then for step 3, we know that step 1 must form two species. It must form Br minus and CH3 3C plus. An important note is that CH3 3C plus is not in the overall equation, so it must be formed in step 1 and used up in step 2. So we call this the intermediate. And so we then get that in step 1, CH3 3C plus and Br minus are formed, and this will be the rate determining step because we're using the only thing that is in the rate equation, which is the CH3 3CBr. And in step 2, we then add OH minus to the cation, which is the intermediate, and then we form the product that we have in the overall equation. And so overall, we've got the equation of adding OH minus to the CH3 3CBr to form the CH3 3COH and Br minus. So two things to take away are that the slow step 1 matches the rate equation. So that's the first thing to check. And the second thing to check will be that the sum of the steps gives the overall equation. And so we can see that because the cation is the intermediate, so that's not involved in the overall equation. But if we add together the CH3CBr, so if we add together this and this, we end up with this and this. And so that equals the overall equation. Now we're going to look at a question. So aqueous iron ions react with aqueous iodide ions as shown below. Initial rates data showed the rate equation to be rate equals K times by the concentration of Fe3 plus multiplied by the concentration of I minus squared. Determine possible two-step mechanism for this reaction. And so from the rate equation, we know that we have to have 1 mole of Fe3 plus and 2 moles of I minus in the rate determining step. So if I have step 1, then we need 1 mole of this Fe3 plus and 2 moles of this I minus. And then I'm going to form this intermediate FeI2. And then for step 2, I need to use another one of these Fe3 pluses because we've got 2 moles in the equation, in the overall equation. And then I'm going to add it with this intermediate because the intermediate isn't included in the overall equation, so it must be used up in the second step. And then I can form 2 Fe2 pluses and an iodine. And then the last thing to do is just check that all the steps add up to the overall equation, and we can see that I have Fe3 plus and 2I minus, and then I've got another Fe3 plus here, and then I form the two Fe2 pluses and an iodine. So everything works.